Assalamualaikum warahmatullahi wabarakatuh and hello to everyone. We are from group 3 in group assignment for Pbl Algebra. We promise you we will give the best presentation for our video. So before I start our presentation, we will look for the content for our presentation. Firstly, we have our introduction for the presentation, then we will introduce our team, the minutes of the meeting, problems, background, and the solution of the case study. Lastly are the discussion and conclusion for our presentation. Then we move to the introduction of our presentation. We usually use progression in our life to solve a problem. The meaning of the progression is a sequence of numbers in which they are arranged in a certain order. The progression is divided into arithmetic progression and geometry progression. We will look for the arithmetic progression first. Arithmetic progression is a sequence of numbers in which each term after the first term is represented by a term A is constructed by adding fixed number. As you can see, there is a formula Tn equal to A plus n minus 1 and d. Next, we move to the geometric progression. A geometric progression is a type of progression with a fixed ratio between each term. The constant ratio between these terms is represented by the term r. As you can see, there is a formula for geometrical progression. Tn equal to arn minus 1. So, I am Muhammad Syazwan Shakir bin Mawadin, the captain from the team.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilan Hakimi bin Muhammad Faizal from Group 3 Algebra.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmed Irfan bin Muhammad Rizwan from Group 3 for Pbl Algebra.
Hi, my name is Muhammad Nabil Farid bin Musa.
So, as you can see, this is our minutes of meeting, which is we use Google Meet meeting and also face-to-face meeting in B404 rooms. So, during the meeting, especially the Google Meet, we discuss about the assignment. We divide job for each teammates, understanding the video. So, next, for the face-to-face meeting, we discuss about the assignment. We update our progress of the assignment, and we also have a reflection session.
I want to talk about problem background. First problem background is salary. Culprit is a diploma holder in civil engineering. After she graduates, she wants to save up some money to continue study in degree, master and PhD. One day, she got a job offer from one of the biggest engineering company. The company offer a salary 50,000 rupee per month with an annual increment of fixed amount 5,000 rupee. She accept the job with full commitment. After a few months and year, she has saved and gathered up enough money to continue her study. Question 1. Culprit want to continue studying in degree, master and PhD. The amount that she need is 100,000 rupee. How long she need to get that amount? Second problem background is bacteria. Small bacteria can fill in the pin over 100,000 per 100. 100,000 per 1,000 bacteria can make 500 people sick by getting infected. Besides this, bacteria also can be produced in grow up of the environment. One of the way to produce itself was splitting in half. It will become a big problem to the people. For the example, 10 bacteria can produce in every 50 minutes. So the colony of 20 bacteria will produce in 30 minutes. Question: 10 bacteria can be produced in every 15 minutes. After 30 minutes, there will be 20 bacteria. How many bacteria can be produced in 1 hour?
For the solution of case studies, in question 1, we use the arithmetic progression, which is the Tn equals to A in brackets n minus 1 close brackets d. In order to find how many years, so we need to find the n term, which is, so we use 100,000 equals to 55,000 plus in brackets n minus 1 close brackets 5,000, and continues with 45,000 equals to in brackets n minus 1 close bracket 5,000, and for the value of n we just put the 5,000 to the right, so it will divide the 45,000 and just minus 1, and we got the n is 10. So culprit need 10 years to save her money until the amount reached to 100,000 rupees. For question 2, we use the geometric progression, which is the Tn equals to AR n minus the power of n minus 1. So to find the fourth term of the progression, we just insert the value of n, which is 4. So we got the answer is the T4 equals to 80. So after 1 hour, there will be 80 bacteria be produced.
For our discussion, we have two discussions. For discussion 1, culprit want to continue her studying. She need about 100,000 rupee for her expenses when she go to study. So the question is, how long she need to save her money up to 100,000 rupee? We answer the question using arithmetic progressions. The formula we use is Tn equal to A plus bracket n minus 1 times D, which the Tn show the final term, which is 100,000 rupee. The A is the first term from the question given, that is 55,000 rupee. The D means the common difference, that is 5,000 rupee. After doing the equation, we knew that the culprit need 10 years to reach the amount she need to continue studying. For discussion 2, we want to find how fast the bacteria reproduce in a timeline at 1 hour. The reason is that we want to know if in the 1 hour of reproduction of bacteria will give massive impact to humans. To solve this problem, we find and solve the solution by using geometric progressions, which is Tn equal to AR power of n minus 1. A equal to first term, R equal to common ratio, and Tn equal to the term. The first terms from the question is 10 bacteria for the first 15 minutes. The common ratio is T2 divided by T1. In 1 hour, we'll have 4 quadrant of 15 minutes. Thus, the Tn is 4. After doing the equation, we knew that the number of bacteria reproduced in an hour is 80.
So this is our conclusion. For conclusion 1, we can conclude that the arithmetic progressions can help solving numeral sequence in various mathematical and real-world contexts like culprit's problem that we just solved. Financial planning for monthly salary can be done easily by using arithmetic progressions.
For the second conclusion, The exponential expansion of bacterial populations can be explained by comprehending the idea of progression in the context of bacterial reproduction. The growth of bacteria through binary fission is characterized by an exponential process which is in the population doubles with every division of the bacterium. This exponential nature emphasizes how important it is to implement prompt management techniques in a variety of industries in order to stop the growth of bacteria. Scientists, medical experts, and environmentalists can create more efficient methods to monitor and control bacterial populations by recognizing and understanding geometric progression. This highlights the crucial function that progression plays in grasping and reducing bacterial infections.
That's all from us. Thank you.